I am Kasper Lund, live in Denmark, and I'm still in Denmark due to various pandemics that you all heard too much about. Traveling is a little bit tough these days, but hopefully it is getting better. So I'm joining you today via sort of a web link here, but I spend my time in sunny Denmark, where I work on all technical matters. Like Seth, my title might say CEO, but I'm certainly still a technical person, and I care a lot about the details. And writing code is my probably my favorite thing. So if you have any sort of technical questions, please do stop me, and I'll be happy to take a shot at that. But yeah, I'm Kasper, and hopefully I can change the screen here. In 2006, I did join Google to build something rather new, and the logo looks like this. And I assume that most people in the audience here actually know about Chrome these days. When I started presenting the work we did on Chrome and went to tech conferences and presented the V8 JavaScript work we did there, I would usually have like a good handful of sort of tech-savvy folks in the audience that knew about Chrome. But over the last few years, it sort of just exploded, right? And I think Chrome now has more than 3 billion installs. So it's like a widely used thing. And in the sort of right at the center of Chrome sits the V8 JavaScript engine that I built from scratch with a team here in Denmark. And that sort of whole experience in building for billions of users was a fantastic journey, and something I'm tremendously proud of having been part of. So maybe not everyone sort of knows about how sort of Chrome came to be and how it all started out. But when Chrome was just about to launch, we had this crazy idea. Marketing had this idea that we wanted to tell the technical story about what Chrome really is, through a cartoon. So we actually had a small sort of comic book, this might change, there we go, produced. And this is the old original Google Chrome logo, if you're familiar with that one. And we had this thing lying around ready to send out, so we could tell the world about the technical stuff inside Chrome. And the content was like cartoony or comic book like, but it was all like technical. How is it built? How does it fit together? What kind of concepts are in play here? And one thing happened, and Chrome was supposed to be fast, but the only thing that apparently was faster than Chrome was the German postal services. They managed to send out this small booklet, this comic book, at least 2 days before they should have. So influential bloggers in Europe got them quite early. So they had never heard about Chrome, didn't know Google was building a browser, and they got this comic with all the details, all the juicy details in there. So quickly someone scanned it, put it online, and for the first couple of days, the only thing people talked about when they talked about the new browser from Chrome or from Google was the technical details, which was fantastic for me as a software engineer. So I just thought that was a clever way of getting it sort of introduced to the world. And inside Chrome, we had this team in Denmark where I sit and where I work that actually built the JavaScript engine. And as Seth mentioned, we've been super happy to get this work impact on the industry. I don't know how many thousands hours of CPU time we've run through the work that we did at that point. But maybe the most important thing was that we did open source it and got it out in the world so that others could get inspired and build even better things either on top or next to it, right? So like Seth mentioned, getting it out there, inspiring others to do great work. So I'm located in Denmark, Aarhus. So when I worked at Google, that was also the location for that. My background is very technical. I worked on virtual machines and programming languages, Java at Sun Microsystems, Chrome and the JavaScript engine that goes in there, and also the Dart programming language that's now the way you write applications using the Flutter framework from Google is also something that I helped bring to life. So as a CEO, I think it's really nice to be sort of deeply involved in the technical trenches here and be able to sort of work at that level, because it makes you make better decisions also in terms of business. So if you think about there's a bit of a lag here whenever I change the slides. Let's see. Here we go. if you think about what really drives me, it's really enabling others to be productive, building frameworks, operating systems, developer tooling, things that make them achieve more and build better and higher level software on top. So this has sort of been my space for the last couple of decades, and I don't see myself leaving it anytime soon. It's just, it's interesting and meaningful to build sort of foundation level software that others can benefit from, and see how others then succeed and build crazy web apps that you never expected when you started working on the JavaScript engine. So this is sort of my field, trying to build software that others can then reuse and build on top of. There's a good reason why I'm in this meeting as well. I share a deep passion for Smalltalk. I think many people don't know where Smalltalk came from and how the impact it has had on the industry. It certainly has had a big impact on my career. I wrote my master's thesis on Smalltalk, using Smalltalk for embedded systems, and it's always been sort of that beautiful language that too few people have heard of and have made use of, but it's really like a tremendously powerful foundation for lots of innovative work. And everything we do today with virtual machines, just-in-time compilers, that whole shebang, like Java, all those things, they sort of have you can sort of trace that back to Smalltalk and some early work in that space. So I think that's a big part of the reason why I feel like this is exactly the right forum to be in for me. So I am really excited to be presenting with Instantiations. I actually work with the group, the partial acquisition from Google. I've worked with some fantastic folks, ex-Instantiation folks at Google. We sort of indirectly collaborated on the Dart and the Flutter ecosystems. And maybe the most important thing is we really have a shared passion for the developer experience and programming languages. So I think couldn't be happier to be able to take part in this event with Instantiations. So in 2018, having worked on all this JavaScript stuff, I learned of the ESP32, like a microcontroller that was finally, I would say, like powerful enough for me to sort of consider running really sophisticated software on top of. It's a dual core 240 megahertz RISC CPU, 0.5 megabyte of RAM approximately, and lots of flash. Comes with Wi-Fi and Bluetooth built in. But even with that package, it still is a microcontroller that can run on batteries not for days or weeks, but for years, because the drain when it goes to sleep is really, really low. And the combination of those two things and the great price point, less than a couple of dollars, makes it possible to use this for pretty much anything, even things where lots of people might have gone and picked the Raspberry Pi up and used it there instead. And with the Raspberry Pi, even though that is a fantastic piece of hardware you can use for a lot of different things, you're still packing a full Linux installation that takes a while to boot up. You cannot really run this on any reasonably sized batteries for years. So they're just like things where this is just a kind of a hard thing to do. And if what you care about is predictable performance and controlling GPIO pins and dealing with peripherals, the Raspberry Pi is just overkill in that context. So these small devices here are just much more well suited for that. And the software that they run on top of that is just, I think, much more appropriate for the kind of things that you really want to do with IoT, right? So here we have a device, a proper IoT device, microcontroller based, that is still powerful enough to go online and use the right crypto protocols to take part in the sort of the open web in a safe and meaningful way. I think that's exciting. At least there in 2018, when I discovered this, I got really excited. But my first thought or worry was that I'm just a software engineer. This looks extremely low level. How can I express myself? How can I write code for a device like this and feel productive? And I looked at what I could get my hands on and what I sort of could get as development tools for this. And I was actually pleasantly surprised. I could find a development framework for C and C++ and assembly on GitHub from the Espressif team, from the hardware team. And in many ways, it was better than I expected, right? But it still forced me to think about the world in terms of C code and low-level instructions. But at least I had a starting point there. But having just started with that and started working on that, I quickly realized that developing for microcontrollers based on that, at least for me as a software engineer that comes from sort of a high level mindset, I still find that experience kind of sucks. I mean, the separation between applications and drivers and the operating system does not really exist. You compile and you link everything together. And you could say that in some ways that's not so bad. I mean, you're probably going to put all the code on the device in one go anyway. But if you think about the separation or the lack of separation between an application you've written and some driver or the operating system, it is kind of scary to think about the fact that your application will always run sort of in kernel mode. And even if you think you're an application developer, you're actually extending the operating system kernel with all your work. So if you make a mistake in your code, there's a pretty big chance that it's not going to work out for the entire system. And I think that's a daunting and problematic place to be for, at least for someone like me who tends to make a lot of mistakes and correct them later. If you look at the system software that you work with, it's a monolith. Right? Everything is linked and needs to fit together. There's no proper componentization of these things. And it's often too many of them are linked or tied to specific hardware, needs complicated recompilation or retargeting to work on different kinds of hardware. One of the beauties of a JavaScript engine, for instance, is that today the browser is powerful enough for lots of applications, so you don't really have to worry about if you run on the latest ARM-based Mac or on a Raspberry Pi, or if you run on an x86-based Windows machine, right? It's all kind of the same thing. But on these devices, with a C compiler in hand, what you're dealing with is very tied to specific hardware. And the languages are low level. I mean, I write tons of C code, so I'm pretty comfortable with it. But still, for me, it's way less productive than a good Smalltalk or Python or Toit experience. So I think there are beautiful things about C and assembly, and I think they're great tools for certain things. But as the only tool for everything IoT related, they do not really sort of hold up. Maybe the worst thing, though, is as a developer, and I sort of mentioned this a bit briefly before, the fact that my application errors can crash the entire device and probably will crash the entire device is not I don't think that's a healthy place to work from, right? That means that you get extremely careful. You rarely update your code. If it works or if it sort of works, you don't want to change it because you're always scared of introducing bugs, at least if you're working on production software. And I think that's just like, if you have a place where you're worried about changing things, and if being extremely conservative in your approach feels right, maybe you're doing something wrong. And this is probably just like reiterating something Seth said earlier, that like the development experience also just feels clunky. Like the fact that if you change something and want to see it on your device, you need to go through the entire compilation process that takes maybe a minute. Then you have to flash it on the device that takes a lot of seconds as well. And suddenly you spent like 5 minutes just waiting for the system to tell you if you improved things or made them worse. That sort of also leads to a very slow and very cumbersome development experience. So I think there's just something missing here. And in spite of what the hardware has become, I'm in awe of the new microcontrollers. You can do wonderful things with them, but the development experience with C and assembly and the low-level tooling, it doesn't compare favorably to desktop or server or even mobile development, which, at least to me as a platforms guy, is a great opportunity, you could say. Let's see if the slide will flip here. There we go. So how can we enable and empower software engineers better? Like what I really want is some way of taking source code in a high-level IDE or Visual Studio Code, for the lack of something Smalltalk-like, and get that code to somehow almost magically just go to the devices using Wi-Fi or a cellular connection and take effect there in a sort of swift and simple way. That's the kind of experience I want as a software engineer, an easy way of dealing with devices and an easy way of getting my code to run on the devices, to maybe fail, but then let me experiment, tinker, learn quickly. So there's something here like that's missing to enable software on one side and the devices sort of to get closer together. And that thing is what I spent the last 4 years building. It's essentially not just a thing. I would say it's two things. On the left, you have an open source language, Toit, for microcontrollers. It's a productive and high level developer tooling for devices like the ESP32. And if you have no C developers on your team, it's not really a problem because you can write your functionality and your code for the devices in a high level and sort of a rich environment. Now, once you have that on your devices sort of become much more sort of meaningful little computers in their own right. And some of the things that we've come to appreciate for the Raspberry Pi and for larger systems is a way of sort of managing code that runs across a fleet of devices. So we sort of built the right-hand side of this equation as well, the cloud-managed containers and microcontrollers, where we offer a full and rich cloud-managed environment for the ESP32, where you can code up against your devices from your own machine and get your code to flow to even a fleet of devices in a very straightforward manner. So we've split the platform in this way. We've open sourced and made the whole foundation for what we do freely available on GitHub, as things apparently should be today. So you can go to the toitlang.org and browse through the links from there and get to the code and the VM implementation if you care about that level. Or you can go to the commercial offering at toit.io, where we offer a way to experience for free still a commercial product that gives you this cloud-managed environment on top of this open and free language implementation of both worlds here, and let you get a productive language, the right tooling there, and then deciding, depending on what you do, you can opt in and choose to use the cloud overlay to this as well. But before we sort of dive into the real technical meat in this session, I just wanted to show you what the architecture of the stack really looks like on the device, because I think it's really important to just paint a picture and have that sort of in your mind as you see how this behaves and how it works in the hands of Mariano and yourselves. So here again you see a split view, right? On the left you have what I would call a traditional stack, where you have hardware at the bottom. You have a sort of a low-level C-based framework, and then you write all your system functionality as firmware that gets compiled and linked together, and it's sort of a one big lump. An error in any piece of that code will take down the entire system functionality, and it's that's just the way it's done, right? So think about it as you compile, build, even the operating system, even the drivers into one lump of code. Now contrast that with the image on the right, which looks much more layered and modularized. You still have the same hardware and the same foundation, the C code at the bottom, but we sneak in this virtual machine, this open source Toit VM that we put, and together with that low level underpinnings, the ESP IDF, that becomes your firmware. But on top of that firmware, we give you a playground where you can install software applications side by side, and these applications can then do sort of high level work. They are isolated from each other, and they're much closer sort of in nature to a process on a real operating system than the kind of functionality that you would build with the traditional stack. So when you sort of run through the examples and see how it works, think about the original code that we put on the devices as the lower levels, and then all the interesting parts is really what you provide when you write your high level applications and deploy them to the device or run examples from the command line or from the web UI. So this is like the right picture to leave you with. I've been working on this since 2018 with a fantastic team in Denmark. Our fundamental approach is really to innovate at the technology level, so you don't have to. Try to make it possible to use some of the most advanced and most modern technologies even if you're not a virtual machine or low-level expert. We believe that we are building the foundation for the future of all microcontroller functionality, and clearly that might be pushing it, because there is a need for low-level code as well. I think there are lots of interesting things happening in that space, but so maybe we should drop the all here and say most instead. But I think it's good to have an ambitious plan. So let's say that we're aiming for all of it. Our goal is really to enable software engineers like you, like my team, to better use their skills, better use their high-level understanding of problems to tackle interesting things, even on battery-operated devices. And I think with that, I'd love to hand it over to Mariano, who could instead of just this sort of abstract describing what it is, actually try to show you. So thank you so much for attending this session so far, and then hopefully now you will get a chance to actually see some real code and some real stuff.